Hi, I'm back here for section 6.2 video on properties of parallelograms. I'm Matt Pouts, and I'm your host for today's show, which is sponsored by United States Postal Service. United States Postal Service covers you with affordable shipping for over 180 countries. That's the United States Postal Service. Now, the United States Postal Service isn't just our sponsor for today. The United States Postal Service also has this wonderful, wonderful shape on their trucks that is in the shape of you can guess it, a parallelogram. Parallelogram, that's not the best outline in the world, but parallelograms are all we're talking about today. So the goal, which you can write down in your goal sheet, is I can use relationships among sides, angles, and diagonals of parallelograms. And that's what we're going to do today. So make sure that's written down. Make sure you think about what you know about those relationships of parallelograms as we get started on today's lesson. So, a couple things to start us off. What is a parallelogram? Well, I'm going to type it out. It's going to be faster for me. A parallelogram, we'll put that in there, we'll lock it there. A parallelogram is a quadrilateral, and we talked about quadrilaterals, those are four-sided figures. A quadrilateral with both sides, or both pairs of opposite sides parallel to each other. So a quadrilateral with both pairs of opposite sides parallel. That's all the definition of a parallelogram is. All right, what does the definition of a parallelogram tell us about parallelogram ABCD? ABCD. Well, we know that opposite sides have to be parallel. So this has to be parallel to this, and this would have to be parallel to this. So we have AB is parallel to CD. Also, segment AC is parallel to segment BD. All right, that is what it tells us about that parallelogram. Now, in that definition, we used opposite sides. If you're wondering what opposite sides are, um, what opposite angles are, consecutive sides, consecutive angles. Um, Oops. That's what we're going to be looking at right here. So opposite sides, really, the only thing about opposite sides that you need to know is they don't share a vertex. So opposite sides in this one would be AC and BD. That's just an example of opposite sides. AB would also be opposite of CD. Opposite angles do not share any common sides. So opposite angles would be angle C, or we'll say angle A, and angle D would be an example. You could also say angle B and C. Consecutive angles are ones that are next to each other, so they do share a common side. So let's say um, angle A and angle B would be consecutive angles. You could also say angle B and angle D, and so on. All right, those are consecutive angles if you're wondering. Now, I've got a couple theorems for you, and I think these theorems are not in your notes, but they are worth writing down. Theorems, we have probably 4 or 5 of them today. Um, Here's Theorem 6.3. Theorem 6.3 says if a quadrilateral is a parallelogram, so we have a quadrilateral that is a parallelogram, so opposite sides are parallel, then the opposite sides are congruent. All right? So opposite sides are congruent in a parallelogram. That's one thing. Theorem 6.4 says if a quadrilateral is a parallelogram, so we have a parallelogram again, then its consecutive angles are supplementary. So we have that A and D would add up to, well, we have A and B would add up to 180, A and D also down here would add up to 180, and so forth. Consecutive angles are supplementary. And if we have a parallelogram again, this is theorem 6.5, then the opposite angles are congruent. So if we look at the picture here, opposite angles B is congruent to D, angle A is congruent to angle C. So, in other words, if a quadrilateral is a parallelogram, then we have a lot that we can say here. We can say, first of all, um, that opposite sides are parallel. We said that in the definition. That is in our definition. All right. Next thing we can say, opposite. Well, let's look at the theorem. Did we say opposite sides are congruent? Next thing we can say, consecutive angles, angles are supplementary, meaning they add up to 180 degrees. And finally, this theorem 6.5, opposite angles are congruent. Those are all four properties of parallelograms. Just any parallelogram, those four properties are true, always. All right, so might do this. We'll just do these first three for sure. We'll maybe leave this one out for right now. But in parallelogram PQRS, this is all it says. We have, and I'll label it PQRS. Measure of angle S is 70 degrees. So we'll go like this. PQRS. There's our parallelogram. PQ is 20. QR is 15. And angle S is 70 degrees. That right there tells you a lot, because we can find just about everything else that we need to find. I know my handwriting isn't the best, but that's hopefully you can read those. All right. Find SR and SP. So the measure of SR and measure of SP. This one would have to be 20 because opposite sides are congruent. So this would have to be 20. SP would have to be congruent to QR, so that would be 15. All right, just from those properties. Find the measure of angle Q. Well, we know that opposite angles are congruent on parallelograms, so that would be 70 degrees. And then we know that consecutive angles are supplementary, so 180 minus 70 would be 110 degrees for angle P. All right, so there's using those properties a little bit. Let's see what this one is real quick. It says, what is measure of angle P if we're looking at this quadrilateral here? This is one that's in your notes, but it's one that I think I added in there. All right. If we know that measure angle S is 64 degrees, what is the measure angle P? Oh, and it's all right here for you. Shoot, I gave it away. Well, we're using the consecutive angles theorem. They're supplementary, so 180 minus 64 would get you C, which is 116. All right, got a couple other theorems for you. There's one about the diagonals. This is a special property about the diagonals of a quadrilateral. And we're going to be looking at diagonals of lots of different shapes. So get this one, put this one in your theorem sheet in your minds. It says theorem 6.6 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember, bisect means they cut in half. Okay? So if we have a parallelogram here, then the diagonals bisect each other, so we have the two halves of the diagonal. It cuts it into two halves of each diagonal. So if we look at an example here, for the parallelogram, find the measure of angles x and y. Well, based on that theorem, we know that this is congruent to this because they cut in half. This is congruent to this. So y equals 3x, according to that right there, and y plus 3 equals 4x. All right? I think you could probably figure out what y is equal to right away. Maybe what x is equal to right away. But we're going to use this as a system of linear equations just to check. We can use substitution because we have y by itself. So let's plug in for y. Let's plug this in for y. And then we'll have 3x plus 3 equals 4x. And subtract both sides by 3x. You end up with 3 is equal to x, or x is equal to 3. Plug that back in for one of these spots, and this would probably be the easiest, and you get y is equal to 9. 3 times 3 is 9. So that is using theorem 6.6, which is all about the diagonals. And there's one more theorem. So it's a little bit more of a funky one. Theorem 6.7. Theorem 6.7 says, if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So this isn't necessarily exactly dealing with parallelograms, but there's parallel lines. So if we have three or more parallel lines and we have a transversal, and if you look right here, um, the transversals, if this is congruent here, then any other transversal here, according to this, then BD is congruent to DF as well. Any other transversal, they would have to be congruent because those parallel lines are going to be equal lengths apart. So if we look at this one down here, here's a couple examples. I know this is a little bit different because we're not dealing exactly with parallelograms, but it's in here for a reason. Um, in the figure, GH is congruent to HI, which is congruent to IJ. So we have these labeled, they're all congruent. That means we have four parallel lines. Any other transversal, the lines would be congruent between them. So find each length. Well, we know that these would all be congruent. So if we know that BC is 5, we need to find EB, so that would be also 5. We can also figure out that CD would be 5 right there. Alright, and then also this other transversal, I'll use red. Since that's 6.5, this is going to be 6.5, this is going to be 6.5. Alright, so they're going to be each 6.5. Wait, AK. Ooh, AK would be all three of them. 6.5 times 3, which would be 18, 19 and a half. Alright, and then AF would be 6.5. Alright? Alright, let's go back then to some parallelogram stuff. I want to go through one proof, and I think that's all we're going to go through. Short proof. Two-column proof. Given that we have two parallelograms, QRST and TSVU, that's all we're given. Two parallelograms. And the picture here. Prove that RQ is congruent to VU. So RQ is congruent to VU. Okay? Well, this one we have, and this is the symbol for parallelograms. I know it's hard to see sometimes. Parallelogram QRST and parallelogram TSVU. That's given. All right. Well, let's look at QRST. According to one of the theorems that we talked about, this would, well, look back. RQ must be congruent to ST. Now let's look back at our theorems as to which one that is. Not on this one, not on this one. Those are opposite sides congruent, and according to theorem 6.3, opposite sides are congruent. We can also then say that, ooh, let's put this all into one. Let's make this a little bit smaller here. Whoops. Lock that in there. I'm going to make that smaller so that I can also say that ST is congruent to VU. And that is because the same theorem. Opposite sides of a parallelogram are congruent. Now, based off of that, and the transitive property of congruence, we can say that RQ, since RQ is congruent to ST and ST is congruent to VU, then RQ is congruent to VU. That is the transitive property. Oops. Property of congruence. And that proves what we're trying to prove right there. All right, that is all we're going to go through for today. I want you to think about the closing question a little bit. It says, what are the values of x and y if you're given all of that? Okay. Um, and I want you to find the error. I believe this is an error analysis one. It doesn't say find the error. I forget, but if there's an error, um, find the error. All right. So again, remember, we can use there's just different relationships among the sides, angles, and diagonals of parallelograms, and all five or so of those, I think five theorems that we did tell us about those relationships. All right, we'll see you next time.